Okay, a very good morning to all. I'm sharing the QR code. Give the QR code and then we will start. Okay, so I think you have given your QR code. Now tell me one by one before going into the bridges. What is Anderson used to measure for? Where
Inductance.
in Anderson
Conductor. Ma'am, capacity.
Yes, Anderson D or T. Inductance is Maxwell, na? Okay. Inductance measurement, what bridges we use? Mainly self-inductance. Yes, Monica?
Hey, ma'am, Maxwell's bridge.
Maxwell and there are one more bridge in your syllabus.
Hayes bridge, ma'am.
Hayes bridge, correct. Hayes and Maxwell, okay. And for Acha, I'm sharing my screen. You just have a look. And for Anderson and D T, what is used for? Capacitance, isn't it? Anderson and D T. Sharing is also capacitance. What is the formula of dissipating factor? What is the formula of dissipation factor in sharing bridge? Tell me. This formula I have derived for you also. In sharing bridge, what is the formula for dissipating factor?
D1 equals to omega R4 into C4.
हाँ, correct. सब पूजा ही आंसर देगा, बाद बाकी लोग क्या करेंगे? What others will do? All answers are given by Pooja and others are not listening. See, unless and until you practice these bridges every day, you won't be able to remember the formula. And in exam time, if you have some questions, short questions, basically, it is not possible for you to do the whole derivation. So it's better you try to remember what is dissipation factor formula, what is Q factor formula. So these things are important. Okay. Acha, Pooja, your problem we will solve at the end. Let us first, this I told you Wien's bridge I left out somehow. So this bridge I want to complete today. After doing Wien's bridge, we will focus on your problem. Okay, yesterday there was some issue in angle in that problem that I will discuss with you. Okay. Now Wien's bridge. Okay. Yes, Pooja. Anything?
No, ma'am.
Okay. We will discuss that problem. Don't worry. At the end of the session, we will discuss. So let me complete this first. Now, Wien's bridge. Our today's topic is Wien's bridge. Wait. Today's topic is Wien's bridge. So Wien's bridge, measurement of frequency, right? It is used to measure the frequency. So Wien's bridge I used in AC circuits for determining the value of unknown frequency. Okay, this bridge measures the frequency from near about 100 hertz, okay, 100 hertz to 100 kilohertz. This is the measuring, I mean, range of Wien's bridge. Okay, accuracy of this bridge, if you say talk about accuracy, accuracy of this bridge, that is lies between 0.1 to 0.5%. Okay, so this is the accuracy of the bridge. And the bridge is used for various other applications also: capacitance measurement, harmonic distortion measurement, then you can say harmonic distortion analyzer, and high frequency oscillator. Okay, so main work of this bridge is to measure frequency. For the source whose frequency has to measure is connected, shown in the figure. Now let me show you the figure first. Okay, let me take you to the figure. Okay, look into this figure. I think this figure is visible to you all. Let me enlarge it. Okay, this is the figure. Now in this figure, see, Wien's bridge is very sensitive. Okay, first topic, if you come in the lab and if you see Wien's bridge, first feature of Wien's bridge is that it is very frequency sensitive. Frequency sensitive. Okay, thereby it is difficult to obtain the balance point here. The input supply voltage here is purely not sinusoidal and they have some harmonics. Okay, now harmonics of the supply voltage, they actually disturbs the balance condition of the bridge. You know that if there are harmonics in any supply or any waveform, it creates some problem in the bridges. So mainly here the input is having some harmonics because the input is not purely sinusoidal here. Okay, so this harmonics actually they actually supply in the supply voltage, they create some disturbances in the condition, in the balance condition of the bridge. So to overcome this problem, actually this harmonic problem mainly, in generally also, if in any circuit you are facing some harmonic problem, we use filter. What is filter? Filter may be inductor, filter may be a capacitor. Okay, so to overcome this problem here in this particular bridge, here also you will see some filter is being connected. The filter is using the bridge. The filter connects in series with the null to the detector. So this picture is okay. I want to show up a different picture. Wait. Here, let me see the picture, what they have done. Okay. Okay. Wait for a second. Let me show you the picture with the help of which we can do the PA. Now, if I take similar, wait, yeah. So I'm taking this, you see what I am drawing. So we need to connect a filter, right? So first of all, I will take here a resistance, then point B, then from here another resistance like this. Okay, and here also another resistance with a capacitor. Here it comes the point, and here also another resistance like this. So this you take as R3, this you take as R4, this you take as R2, this you take as C2, and this here you will connect this portion, definitely it will be R1, and here you will connect a C1, okay, in parallel to it, C1 like this. Clear? Now detector, here you have to take balancing detector like this. Let me connect the equation, connect the circuit. This is the supply. This is a supply, and here I need to show you 1 second. Achha, the connection diagram you just now see, a mechanical coupling will be done here. Okay, how? If this is the terminal A, this is terminal B, this is terminal C, this is terminal D. Okay, and current I1 will be flowing through here, and definitely through here current I2 will be flowing this portion. Okay, I2 is flowing, and through here also I2, or you can say I4. As I told you, I2 is equals to I4 here, and here also you can take current I1 because this current is coming to R3. So you can say I1 is equal to I3 and I2 is equal to I4. Okay, and this portion is definitely, it is I'm denoting as V1, and this balance portion is V3. Okay, again this portion is V2 and this portion is V4. Okay, now let us see the coupling portion here. From this resistance to this resistance, a mechanical coupling is being done here between these two. This we call as mechanical coupling. Okay, rest of things are same. So you see here what we have done. Now when the bridge is in balanced condition, so you see the potential at node B, this is my node B, and the C are equal. Okay, so that means we can say V1 is equal to V2 and V3 is equal to V4. Clear? Now the phase and magnitude of V3, we can write what? V3 I can write I1 R3 because I1 current is flowing now. And for V4, I can write I2 R4. Okay. If I do any mistake, do let me know. Now these two are equal and they are overlapping each other. Okay. So the current I1 that is flowing through the arm BD, which is the BD arm, this is the BD arm. So through BD arm also current I1 will be flowing. And the current I2 flowing through the R4, this through R4, they are also along with the phase, okay, with the I1 and this I2 R4 and I1 R3. Now total voltage drop across the arm AC, which is the arm AC, this is arm A and this is arm AC, okay, that will be equal to the sum of the voltage drop, that is I2R here, I2R2 in this particular arm across resistance R2, and the capacitive drop will be somehow here in case of capacitive drop, in case of, you can say, this arm AD, it will be somehow I2 divided by omega C2. Okay, this is across the capacitance C2. And when the bridge is in a balanced condition, we can say V1 is equal to V. Both are equal in magnitude and phase. Now, the phase of the voltage V1 and the voltage drop across V1, what it will be, means here. So if you consider this portion as R1, okay, so current IR is flowing through it. So we can say that the voltage drop across V1, and that will be equal to IR R1. Okay, across the arm R1 is also same. So resistance R1 is same as the is in same phase as that of the voltage V1. So the phasor sum of V1 and V3 and V2 and V4 will give a result in the voltage supply. So that we will see in the phasor diagram. Now let me show you at balance condition, what can we write? At balance condition, what can I write? R1 in place of Z1, what can I write? I can write R1 divided by 1 plus j omega C1 R1. Okay. Multiplied by R4 because the formula is Z1, Z4 multiplied by, sorry, Z1, Z4 equal to Z2, Z3. So in place of Z2, what can I write? In place of Z2, I think this will be somehow R2 minus 1 by omega C2, okay? And here in case of, we will write here R3. So once you equate the real part, then what you will get? If you're equating the real part, I think we will be getting real part if I equate. So R1, R4, C2 will be equal to R2, C2, R3 plus R3, C1, R1. You just open the equation and you will get something like this. Then you just divide all the terms with R1, R3, C2. I'm moving to the next page. Dividing all the terms with R1, R3, C2. After doing what we will get, see the actual equation was this: R1, R4, C2, R2, C2, R3 plus R3, C1, R1. If you divide it with R1, R3, C2, here also R1, R3, C2, and here also R1, R3, C2, then what you will get? R1, R1 cancel out, C2, C2 cancel out. Here R3, R3 cancel out, C2, C2 cancel out, and here R3, R3 cancel out, and here R1, R1 cancel out. So I think I can obtain R4 by R3 is equals to R2 by R1 plus C1 by C2. Okay, now comparing the imaginary part. Imaginary part, if I compare, then I will get something R3, R2, omega squared, C2, C1, R1, this is equal to R3. Okay. So if you see, if this will cut out R3, R3. Okay, so you will get somehow R2 omega squared C2 C1 R1 equals to 1. From here you can get omega also. That will be root over, you need the frequency, right? So R1, R2, C1, C2. So omega we also know what? Omega is 2 pi f. Clear? So f, what we can write? F is what? Omega by 2 pi. Omega by 2 pi. Okay. You know omega. You know omega. So just put the value of omega here. Yes. So we can write here 2 pi and we will put the values R1, R2, C1, C2. So what I required the frequency because I was about to measure the frequency. So the slider of the resistance, I'm going to back to my diagram. You look here. This is the slider resistance R1 and R2. Okay, which is having a mechanical coupling. So the slider of resistance R1, R2 mechanical connect to each other. So we can see here R1 is equal to R2. It is obtained from this picture. Okay, so this is the thing that how you are about to find out the frequency from this particular equations. Okay, now let us move to my the phasor diagram once. Let me show you. Wait. Okay, here in this picture, the difference is nothing. Here you see only according to my picture, you will see what I have done in the whiteboard. There, this total portion I did in R1 and this R1 C1 I shifted here in R2. This is the only difference, nothing else. But whatever you do, the result will be same. And here R3 and R4 are the variable resistances. Okay. Now let us check out once the equations, what they have done here. See, you can follow any one of them. These notes I have uploaded, you can see. So see, here again, Z1 and Z2, they have find it out, and ultimately you have to equate the real and the imaginary part. Okay, wait. Okay, now let us check out the phasor diagram. Phasor diagram, wind bridge is very important. See, phasor diagram, how they have drawn. First of all, I told you resultant will come here in this A because I told you that one capacitance is connected in R2. Okay, R2 with resistance R2. So you see here, I1, R1, I mean, first how they are drawing, they are taking the reference, this line, this straight line. So here I1, R1, then E2, E3, E4, or you can say V3, V4, whatever. V3, V4 equal to I1, I3. Okay, because I1 current that's been flowing in R3 resistance, we will call it I1, we can also call it. Okay, now see I2, R2, that portion will be negative direction because you are because you have to see if this is our I mean this is our picture and this is something we can take it 180 degree. So here it is going in the negative direction. So they are taking this as reference line, and here in the negative direction they have taken the angles as 90 up to here, and rest of the thing they have drawn like this. Okay, Now this line is parallel to this line. We have drawn this line. Okay, parallel to this line, I have taken this line. Parallel to this line, I have taken this line. Okay, and parallel to somehow this line has been drawn and this line has been drawn. Okay, so this diagram is particularly based upon the picture that you are taking as a circuit diagram. So IC2 is definitely for the capacitor, and definitely whatever the C2 current is flowing, that has to be equal to the I2 current, because C2 is situated in which arm through which I2 is flowing. So this one is parallel to this one. Okay, like this wise they have taken the diagram. So in your question paper, if they ask you for the phasor diagram, then only you can go for it. Otherwise, not required that much. Only just have an idea that these bridges have their own phasor diagram. That is important. Okay. See here, comparing the real and the term. Here we have shown here that how we can find out the F. This is the F that we are getting. Now, some note has been given here in my notes. Let us check it out. What is that? The above bridge can be used for measurement of capacitance. As I told you that Wien's bridge can be also used for measuring capacitance, but let it be, though we are only focusing on the measurement of frequency. So we will only focus on the measurement of that. So we will not go through the measurement of capacitance with the help of Wien's bridge. Okay. Now, high voltage sharing bridge I have discussed with you. Now, Wagner, all these things you don't have in your syllabus. So, but in my notes is present, so it's not in your syllabus. Now, yesterday's question. Let us come to that particular point. Yesterday's question. What was that? Now, let me see the question first. You also see in your copy. The question was an AC bridge circuit working. This question, anybody has done? Pooja is having some problem. Working at 1000 Hertz, arm AB is a 0.2 microfarad pure capacitance, arm BC 500 pure resistance, and CD contains unknown impedance. Arm DA has a 300 ohm resistance in parallel with a 0.1 microfarad capacitor. Find R and C or L constants of the arm CD, considering it a series circuit. Okay, this problem, I did some portion and I told you to find out the value of R. Acha. So forget about that. Today I'll do the fresh sum. Now, first of you tell me, do you know how to convert? I mean, do you have idea that suppose we have a term 98.8 minus J 52.2. How to convert this term into angle form? Angle form means like suppose if I don't know the answer, but suppose this form gives me something like this. Okay, something like this. Do you know how to convert from J imaginary term to angle term? First, you tell me this thing. Then only we will proceed with this problem. Otherwise, we will stop here. Tell me, do you know that how we can convert this J term to angle term? Yes, at the sum you are not clear.
मैम नहीं जानते, बता दीजिए.
नहीं जानते तो फिर तो ये problem, then I have to explain the whole that thing, that how you can convert J term to angle term, then only you can do this problem. But this was in your mathematics, right? In 11-12 you must have learned this. This is the polar form and all. I mean, this actually depicts something, you know, cos theta plus I sin theta. And this you can, how you can convert from imaginary to angle to radian or something. It's just like that. How you are not able to do this? This is in mathematics in your class 11-12. 11-12 you had complex number in polar form to angle to angular form. Okay, first let me then tell you that thing, that how you can convert it. Okay, otherwise no use of telling you this sum. Okay, suppose Suppose you have a complex number in polar form. Let me tell you with example. Suppose 5 plus 2y. Okay, 5 plus 2y. A very simple, with a very simple thing I'm starting. Now, polar form of this complex number means polar form of a complex number, what we can write? Polar form of a complex number, it is z equals to a plus bi. Okay, that we can write, that is z equals to r cos theta plus I sin theta. Okay, so you have to first find the absolute value of r. Clear, this r. So what will be that? R will be mod of z. So that will be equal to a square plus b square. Okay, so here what you will be having? My a is 5 and my b is what? B is 2. So if I do the calculation, I will get something root over 29. So what is the root over 29? Kya aayega? Do the calculation, tell me the value. Hmm?
5.38.
Yes, 5.39, something like that it will come. Now you have to find out this theta. Find the argument theta. This is every time you will be requiring this thing. Okay, theta. So since a should be always greater than 0, so we can use the formula theta equals to tan inverse b by a. Okay. So anywhere if you see this kind of thing, you can use this. Okay. Tan inverse b by a. So theta, what it will become? Tan inverse, my b is 2 and my a is 5. So it will dekho what it's coming. Tell me.
I'm 21.8.
Okay, wait. $21.8, right? Wait. 21.8. No, it will not come. In my calculator, it is coming 0.38. Check it out. 0.38, something it will come. You have done something wrong. Okay. So you got theta. So the polar form of 5 plus 2i, you can write like what? 5.39 cos 0.38 plus I sin 0.38. This is one form. Okay. This is one form of writing the complex number, polar form of complex number. Second form, this is clear how we are doing this, how we are writing the I form into sine and cos. This is one thing. You have to find out the angle. You have to find out the value of the R also. Okay. This is one form. Second, let me tell you one thing. I think it is done. I can go to next sheet. I can go to next sheet.
Yes, ma'am.
Okay. So in the next thing, another thing is that about J. What is J? You have done in your in complex number in 11, 12. You must know J is equal to root over -1. We can write this. We can write this. Okay, imaginary form. So what we need to do, if you are told to calculate suppose wait. Suppose you are having 56.00 angle 27.00. How you will convert this into J term? How you will convert this into J term? Can you tell me? I mean, this you can say polar to rectangular. Polar to rectangular conversion. Okay. How you can do it? Or we can see either we can do in degrees, we can do in radian, both we can do. So I have taken, let me first tell you in degree. Okay, then we will do in radian. So this is 56.00 angle 27.00 degree. Clear? So what can I write from here? How you can do? Tell me the answer or the way, method. These things are very basic. And these things now I have to tell you. 27.00 degree plus J sine 27.00 degree. Okay. So it will be 49, see 49.90 maybe, and plus 25. If you solve it out, do the calculation part, 0.42 J. This is, or J you can also write in the front of 25, not an issue. This same thing you will do also in radian. So let me also do that for you. 56.00 in radian, 0.47 it will become this 27 degree. So how you can convert 56.00 cos 0.47 plus J sine 0.47. Tell me the value. Tell me the value what you will get. You will get the same value. Okay, 49.90 plus J 25.42. This is the way. This is the way of conversion of polar to rectangular. Okay. Now we will do rectangular to polar. Means if you are given 49.90 and imaginary 25.42, then how you will convert it into angle? That is important. Okay. So I'm going to the next page. These things are very basic. I don't know why you people don't know. Next is rectangular to polar. So the previous one was polar to rectangular. I did both in degree as well as in case of radian. Okay. So now if you have 49.90 plus J 25.42, something like that. How you will convert this into your polar form? First of all, you have to find out the R. How you will find out R? 49.90 whole square, A square plus B square. 25.42 whole square. Do the calculation, tell me the answer. Theta you have to, yes, 56. 56.00 it will come. Tell me the theta. Theta will be what? Tan? Right. Tan what? Tan inverse?
Tan inverse
25.42 divided by 49.90. What is the value coming? It will come somehow 0.47. Okay. 0.47. So 49.90 plus 25.42 J, we can write 56.00 angle 0.47. So this is the way how we can convert any imaginary term into polar form. Okay, so radius, if you are asked, radius is 56.00 and theta is here obviously 27.00 degree, but if you convert this into radian, it will be 0.47 radian. Okay, and if you are asked to find out, actually in this case we depict this kind of diagram because here you know what is your x. Your x is 49.90 and your y is 25.42. Okay, so if you draw a plot, if you do the plotting, it will be somehow, you know, at this point. if this you take your 50 and this is the P point, polar plotting, and this is the 0. So it will be somehow, the plotting will be somehow like this. Do the plotting. Okay, so polar plot is very, these things in mathematics you had, in control system you had polar plotting and all. Okay, so this is the basic method how you convert any J term into radian or degree. Clear this portion? Okay, one more thing. Suppose if you're having, you can, I mean, here I have written 0.47 that I have written in radian. You can also take this in 27.00 degree as per your wish. Here also 56.00 I have done it in radian. You can also write 56.00 angle of 27.00 degree. Okay. This thing can be also done if you want. So basic equation which comes, I told you, r cos theta plus j sin theta. From that you have to find out. So similarly, you can do the same for any. Let me see how much time is left out. Okay, time is running out. First, let me share once the QR code. Okay, if anybody has left out. 1 minute, रुको. Time खत्म होता जा रहा है. Anybody is came late, give the QR code fast. Next day, I will show you some more polar form problems.